quadratic into the quadratic formula, but we're going to go ahead and just kind of skip that for now. So what we get here is for quadratic formula, it will be x is equal to, thank you. Wait, what am I saying? X is equal to negative b plus or minus the square root of b squared minus 4ac all over, okay, 2a. All right, that's our quadratic formula. I apologize for the messy writing. Okay. You question how people memorize this formula with the song? Well, the song is like Pop Goes the Weasel. So it's dun 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 dun. So if you put the formula into that beat, then you know you get the formula, you get the little tune. Okay. I'm not gonna sing it because I'm recording the video too, so that's it's a little embarrassing. All right, let me pull up the first examples here. I have them on my phone. Okay, so whenever you're solving a quadratic, now you have multiple methods. You can use complete the square, which is effective and it works every time, but it can also be quite a lot of work, right? It involves being very comfortable with factoring. It involves being very comfortable with manipulating the solution, making sure you're not combining parts of the answer incorrectly. The quadratic formula can save yourself a little bit of time. It can also save some of that load of how many steps, what do I need to do for complete the square, right? It can be a little bit challenging, all right? So with quadratic formula, and if you have a quadratic already that you're looking to solve, typically the only requirement is that everything be on the same side, right? So it's the opposite of complete the square. Complete the square has you move parts around. With quadratic formula, you want A, B, and C all to be on the same side. Okay, so for example, if we have a quadratic that says 3x squared plus x plus 1 is equal to 0. This is essentially how you want your quadratic to look before you start plugging in values for A and B and C into the formula, okay? You want all terms on the same side. It doesn't matter if they're all on the right or if they're all on the left. It doesn't matter, the solution will still generate the same, but they all have to be on the same side, okay? With the formula, you have to clearly identify what is your A, what is your B, and what is your C. And sometimes that can be tricky because many times the mistake is that you include the variable as part of your A. The A, the B, and the C. A is a coefficient. A coefficient is simply a number. B is a coefficient. It's a number. C is a constant. A constant is a number. Okay, so in this case, if you're looking to identify A, B, and C, first make sure that you can clearly see the coefficient for each part of your quadratic. In the event of, let's say, 3x squared, you can tell that clearly this is going to be your A value, okay? A, again, is only the number, not the variable. With B, you don't see a number, so go ahead and then include your invisible 1. That means B is just going to be a 1. That's okay. All right, so just the 1, that's your B. And then your C value is your constant, okay? Now, the other thing to include is to make sure that you include that sign, right? Because here B is a positive 1 and C is also a positive 1, okay? A is obviously a positive 3. But sometimes you might have like -1, and then in that case, C is going to be -1, all right? So then in this case, you know that A is 3, B is +1, and C is 1. So sometimes it's nice to kind of like take those numbers out of the quadratic and then just write them on the side, and then you can just go back in and plug them into the formula. Okay, so you have x is equal to, remember that the formula starts with negative, there's a negative there, okay? So you always write the negative, And then whatever comes next, let's say it's your b, put that in parentheses, okay? The negative outside of the parentheses is part of the formula, so it always has to be there, all right? Then you get plus or minus the square root of b squared. In this case, that's just 1 squared. Minus 4 times a is 3, times c, which is 1, all over 2a, and a is 3, okay? So the denominator there expands and covers the entire numerator, all right? So sometimes I see the mistake of people writing, they put like the division just right here, and they leave out the very beginning of the quadratic formula. That's not the case, okay? The line extends and it covers everything, all right? So that denominator is the denominator for the whole numerator, all right? And so then from here, it's just a cleanup process. So we'll go ahead and we can say now that x will be equal to, well, negative times 1 is a negative 1, plus or minus the square root of, here that's 1, right? Minus 4 times 3, well, 4 times 3 is 12, and 12 times 1 is just 12. So you get 1 minus 12 all over 6. Okay? All right, so now we clean up the inside of the square root. So then that takes us to, let's go over here, x equals negative 1 plus or minus the square root of 1 minus 12 will be negative 11 all over 6, right? You see how I'm consistently leaving 6 as the denominator for the whole thing, okay? Now finally, notice how you have a square root with a negative value inside. You're gonna have to convert that negative into a imaginary. Sorry, I blanked out for a second. So x is going to equal negative 1 plus or minus the square root of 11i all over 6, okay? And so there you have your two solutions, right? If you really wanted to, and sometimes you might see this variation of the solution, is that because 6 is the denominator for the whole thing, sometimes you'll see it split apart. So sometimes you might see it as x is equal to negative 1 over 6 plus or minus root 11i all over 6. Okay, sometimes you see it written that way, okay? But it's the same, right? Because the same denominator allows you to combine the numerator. So it's basically just the variation from one to the other. Okay, any questions on that so far? So notice my solution, nowhere in there did I end up with x, except for the part that says x equals, right? Because x is what I'm solving for. Remember, we're solving for something. So x, that's the only place x is allowed to be, x equals. And then the rest should only be numbers, maybe an I in there, depending on if it's imaginary or not. Okay, but please do not include x as part of a, right? Don't plug in 3x into the formula. Don't plug in 1x into the all right? Okay. Any questions so far? How we doing? So far, so good. See a thumbs up. Cool, cool. No questions? All right. Okay, cool. Let's move on to another one. Let's try example 2. All right, let me pull it up. All right, so let's try this now. Okay, we have 5y to the third. I'm sorry, not y to the third, y squared is equal to 6y minus 3. Okay, so here is an example where you will need to take a little bit of time to rearrange the quadratic, all right? You need it in standard form. At the moment, it's not, because you have the ax squared part separate from the bx and the c. So you need to move everything to one side. So just make a choice, okay? Let's move everything to the left, all right? So first, you want to subtract the 6y from both sides, and you want to add the 3, okay? So on your right side, these terms will cancel out. And then on the left side, you should be left with the expression 5y squared minus 6y plus 3 is equal to 0. Okay. Now you're in a position to collect A, B, and C, and then plug them into the quadratic formula. A common mistake that I notice is also that some students won't transfer the terms, and then they'll just collect A, B, and C from the original equation. And why would that be wrong? Because the quadratic was never in standard form. So the quadratic formula only works is if you have the quadratic in standard form first. All right. Otherwise, your B is going to be the opposite sign, and your C is also going to be the opposite sign. Excuse me. Okay. So move everything to the left or move everything to the right, doesn't matter. And now you can go ahead and identify what is my A, what is my B, what is my C. Okay. So in this case, 5 is going to be our A, -6 is going to be our B, and +3 is going to be our C. Okay. So if you want to, you can then write them off to the side. A is 5, B is -6, C is a 3. Okay. All right, so now let's plug in quadratic formula here. X will equal negative. You see why it's important to then put parentheses after that original negative is because now look at my B. My B is -6, right? So I have a negative from the outside because it's part of the formula. And then B, the value of B is -6. So I have two negatives, right? Which will eventually turn that 6 into a positive. Plus or minus the square root of B squared. Because you're dealing with a -6 as your value, this is when it's important to place that number inside of a parentheses, and then you square it. Because what you're saying is that it's -6 times -6. If you don't put the parentheses around the -6, and you're using a calculator, sometimes the calculator gives you the wrong value, right? It might give you -36 instead of +36. Okay, so when in doubt, wrap that number in a parenthesis and then square it so that you get the correct value as an output. All right. Okay, so then we have -4 times A is 5, times C is 3. Okay, and then this is all over 2 times A, and A is 5. Okay, so we got some cleaning up to do here. We end up with X is equal to negative times negative. That's going to be a +6, plus or minus the square root of, well, -6 squared, that's where it becomes important, right? Because a negative times a negative is a positive, so we get +36 minus 4 times 5 is 20, and 20 times 3 is 60, so it's -60 all over, oh, that's supposed to be a 1, all over 10, okay? So let's go ahead, take it back up, and then let's clean it up. So we have to clean up the inside of the square root there. 36 minus 60, that should be 24, I believe. Yeah. So we get X equals 6 plus or minus square root of 24. Oh, -24, sorry. All over 10. Okay, so two things there. First, you want to make sure that you convert that into an imaginary, you extract the I, and then second, you simplify the 24 because that can be factor treed, and you can simplify that square root. Okay, so first let's extract the I. So we have 6 plus or minus root 24I all over 10. And now we can simplify that 24. Okay, so maybe back here on the side, we take 24, we factor tree it. What's a good one? 6 times 4 maybe. Yeah, let's do 4 times 6. 4 then factors into 2 times 2. So we have a pair. And 6 factors into 3 times 2. Okay, so since there's no pair there, well, that means that both of these are part of the box. Okay, separately. All right, so then in that case, the pair, the 2, that goes on the outside. Inside of the square root, you put both numbers that were boxed. So it was 3 times the 2. So then this eventually just becomes 2 root 6. Okay, so the simplification of square root of 24 is a 2 root 6. Okay, so then we can say X is equal to 6 plus or minus 2 root 6 with the I outside all over 10. Okay, This is then where sometimes it becomes easier to simplify this once you've split it up, right? We talked about splitting it up in the previous problem, right? Splitting up the numerator into two parts. We can do that here because there is some simplification that can be done even further. Watch this. If I take x is equal to, and I split this up as 6 over 10, plus or minus 2 root 6I over 10, notice the numerator and the denominator, they have common factor, right? You can divide the top and the bottom by 2. So if you do so, if you divide this by 2, you end up with 3. You divide this by 2, you end up with 5. Okay? The same thing can be done here with the coefficient of 2 and the denominator, right? You're not going to simplify the square root of 6. Remember that square root of 6 is trapped inside the square root, and you can't clean that up. However, the number on the outside can be simplified with the denominator at times. Okay, so then in this case, if you divide the 2 by a common factor, well, you can divide it by 2, you end up with 1. If you divide the bottom by 2, you end up with 5. Okay, so now your final answer in a simplified form can be x is equal to 3 over 5 plus or minus. You can use the 1 or you can just choose not to use it. I'm going to use it just to show you that you would then simplify that into 1 times the square root of 6i all over 5. Okay, so it's easier to see how that can be simplified after you split it. All right, sometimes you'll split it and then there's nothing to simplify, but other times there will be, like there was in this case. And so there's our solution. Okay, most of the time, if you can get to this point, even if you didn't simplify, you're doing a pretty good job. But you always want to make sure you simplify your solutions or your fractions. Make sure that they're in the simplest form possible. Okay. Any questions for me up to this point? How do we feel? We're okay so far? See a thumbs up. All right. Good. Cool, cool, cool. All right, looks good. All right. Okay, let's try maybe one more, and then we have got some word problems to do today. Okay. All right. Let me zoom out of here. Okay, example number 3. So quadratic here would be 3r squared minus 7 is equal to 6r. All right. So again, I have a quadratic, but it's not in standard form. So you want to convert to standard form first. Subtract 6r from both sides. That's going to cancel out for us. So we end up with a new expression of 3r squared minus 6r minus 7 is equal to 0, right? Notice that I put negative 6r in the middle. That's where it belongs, right? Because you have descending order of power. R to the second, then R to the first, and then you have your constant, okay? So you want to make sure that it's in the correct order, because if not, you're going to have the wrong B and the wrong C. They're going to be in the wrong spot, okay? So make sure that they are in the consecutive order. So now, highlight what my A value is. My A value is going to be 3. Highlight my B value. B is going to be negative 6. And highlight C value. That's going to be negative 7. Okay. So now we can go ahead and plug into the formula. X will equal negative, in this case, my B, right? You see B is a negative. So then again, parentheses, negative 6 plus or minus the square root. Ooh, what happened? Okay. The square root of B squared, right? Because B is negative, make sure you use your parentheses. Negative 6 squared minus 4 times A. A is 3 Whoa. A is 3, and my C is a -7. Okay, so then that's -7 there. All over 2 times A, and that's 2 times 3. Okay, so let's clean up. Negative times negative, x will give us a +6 plus or minus a square root of, well, -6 squared. Again, that's a negative times a negative, so we get a +36. Here, just be mindful of your sign. Identify what you're multiplying, right? Here you have a -4 times 3, right? So that's -12. But then you multiply that times -7. So -12 times -7 will be a +84. Okay. All over. Here you should get 6. All right. Okay, good. So at least we don't have any imaginary this time, right? We have 2 positive values. We can add them up. Okay, so now we get x is equal to 6 plus or minus the square root of, I believe that's going to get us to 120, right? All over 6. Okay, so now the big thing here is now to simplify that square root of 120. 120 is kind of a large value, so we might need some space here for a factor tree. So let's start 120. Anybody have any good ideas into what to factor it into so we don't have to keep going forever? Yeah, we could try 12 and 10. Let's see where that goes. 12 times 10. Okay, 10 is nice. It's only 5 times 2. 12, we can do 4 and 3. Right, so far no pairs. And then you get here, factors of 4 is 2 times 2. Excuse me. All right, so 4 factored into 2 times 2. And then you actually have 3 loners there, right? So each one of these gets boxed up. All right, so that tells us that 2 will be on the outside with a square root of, and then those 3 factors go back inside and you'll have to multiply them together. So then what you end up with is 2 root 30. Okay, so 30 cannot be simplified any further. So then it can then simply convert the square root of 120 to 2 root 30, all right? So now let's kind of move across this way. We can say that 6, or x is equal to 6 plus or minus 2 root 30 all over 6, right? So here, I don't know if you can tell, but we're going to be able to simplify some stuff here because the numerators and the denominator have common factors, right? So we can simplify. So go ahead and split this up. And you can say 6 over 6 plus or minus 2 root 30 over 6, okay? And then you can kind of see what's happening there. 6 divided by 6, that's just going to become 1. That's okay. You can just write 1 plus or minus. And then here, right, both top and bottom, 2 and 6 can both be divided by 2. So that becomes 1, and that becomes 3. So then when you clean this up, you can choose to use the 1 or not. This time I won't use the 1. And you can just leave this as a square root of 30 all over 3. And then this, right, obviously x is equal to, this is a perfectly good answer as is, okay? Okay. Any questions for me so far? No questions. All right. Cool, cool. Okay. All right, so here comes the tough part. Okay, so we have a couple of challenging, somewhat challenging word problems. Let's see if we can work our way through them. Okay, so let me go ahead and let me write this out for you. Okay, so for example number 4, here's our scenario. Okay, so a scenario here, we have a swimming pool. 6 meters wide and 10 meters long. Yeah, you're gonna want to write the question down. Okay. A swimming pool is 6 meters wide and 10 meters long. It is surrounded by a walkway of uniform width. Okay. The area of the walk happens to equal, whoops, the area of the pool. Okay. So what is the width of the walkway? Okay, so I'll give you a second to copy that down. But I'm gonna start here with just like drawing a little diagram. Okay, so I'll give you a few seconds to catch up. All right, so go ahead and give me a thumbs up once you're ready, once you've been able to copy down the problem. Okay, I think we're ready. All right, so let's start with what we're given, right? We have a pool that's 6 meters wide and 10 meters long, right? So let's sketch that out. Let's get a diagram going, and then from there we can kind of fill in the rest of the details. Okay, so let me see if I can sketch out a little rectangle here. Okay, so let's say that's my pool, right? So if I have a length of 10 meters, right? So I have 10 meters long, and then I have something that is 6 meters wide, right? There's my pool, right? And fill it up with some water. Okay, that's our pool. Then it talks about the fact that then it's surrounded by a walkway of uniform width, right? So if you've ever gone, I mean, if you've ever been, I'm sure most of you have probably been to a pool, hopefully, but typically the pools are surrounded by like a concrete walkway, right? Typically it's not like grass and then pool immediately. They put this walkway around it um, for safety reasons or whatever, right? But the fact that the key word here is uniform, that means that uniform width means that it's the same width all around the pool, right? So if I were to go ahead and maybe sketch out something that represents the walkway, let's say then that it would be, let's say, this wide, okay, the entire way around the pool. Okay, so you guys with me there so far, right? So that represents, let's say that what I outlined in green, then that means that everything in between the edge of the pool to the dash line, that represents like the concrete walkway around the pool, right? Okay, we know it's uniform, but we just don't know how wide that piece is, right? We know it's the same size everywhere, okay, but we just don't know, right? That's what we're being asked to do. What is the width, right? What is the width of the walkway? Okay, so because we don't know, then that's going to be our variable, right? That's the one thing that we're looking for. All right, so then let me try to break this up into parts, okay? Because the walkway um, extends all the way around, and then I have some information that the area of the walk, right? The area of the entire walkway is also is equal to the area of the pool, right? So let's see if we can break this up into sections. So I want to know how, basically, how wide is this piece right here? How wide is this, right? That's the walkway right there, right? That's the width, right? So we can utilize X to represent that width, okay? That same width that is going across this way is the same width that shows up here, right? It's the width between this edge of the pool to this edge of the pool, okay? So if it's the same length on this side as X, then that means on this side, this width is X, right? Because that's what makes it uniform, all right? Okay, so now, if I were to go ahead and just kind of break this up into sections, I'm gonna break it up here and there, here and here, here and here, okay? And each one of these, right, the width is X. Okay, so try to follow with me here. So the first thing we're told is that the walkway has an area of equal to the pool. Well, I know what the area of the pool is because I can see that that's just 6 times 10. That gives me the area of the inside. So whatever my area ends up being for the walkway, well, it's going to equal 60. Okay, so I know that because that I got from my length times my width, right? This is the pool. Okay, all right. Now, how can I find the area of just the walkway? Because I know that the area of the walkway is going to be represented by just the outer edge, right? This outer piece. Let me color this in gray, right? So all of this gray area, this is my concrete. And each one of those pieces added up together should equal the same area as what's in the pool, okay? All right, so now, let's say I wanted to find the area for just this little section right here. Right, what would the area for that section be? Okay, it doesn't have any numbers attached to it, but I know the dimensions of that little corner, right? So wouldn't that area be x times x, which is just, yeah, x to the power of 2, good, right? Oh, wait, hold on, let's go back. Okay, so my little blue section here in the corner, that's x squared, right? That's the area there. Would you then agree that that means that every little corner on the outer edges is also x squared, right? So the area here is x squared, the area here is x squared, the area here is x squared. Okay, good, right? So at least we have that, right? Which means that in total, isn't that 1x squared plus 1x squared plus 1x squared plus 1x squared? So that's 4x squared, right? The area of just those corners is 4x squared. So then maybe I can start setting up an equation here where I know that whatever I get from the walkway, let's say walkway is going to be on the left, and then the pool, the area of the pool is going to be on the right. We already established that the area of the pool is 60. So that means that everything that comes from the area of the walkway, we can write on the left side. So we already said that there's 4 of those x squared, so we have 4x squared, okay? But there's still more area to calculate, right? Because those are just the corners. What about this piece right here, the long piece? How could I find the area for this part of the walkway? Yeah, that would be 10x, right? Because if you know that the length going down the long side of the pool is 10, well, you can find the area by multiplying 10, which is the length, times the width, which is x, right? So that gives you 10x, okay? But would you agree that there's 2 of those? So then the area for the yellow is represented by 10x, and the area for the yellow on this side is also represented by 10x. So if it's 10x plus 10x, well then that's another additional area to my walkway. I can add 20x. Okay, 10 plus 10 is 20. Okay, and now the last part we need to find, let's color it in green, right? What would the area for this green part be now? Just 6? Yeah, 6x, right? Because you're looking for the area, so you take the length times the width, right? The width is x and the length is 6. So then here you're getting an area of, what color have I not used? Yeah, let's use this. Right, so we get an area of 6x from this side of the walkway, but then there's another side on this part here. Right, so then from there, we can also identify that this part is 6x, right? So 6x plus 6x, then that gives us a total of 12x. Okay, so now my walkway is the area of those 3 parts, the corners of the pool, the 2 long parts of the walkway, and then the 2 short parts of the walkway. If I add all of those sections up, the area of the walkway, not including the pool, just the area of the walkway, would be represented by 4x squared plus 20x plus 12, okay? So let me clean this up. So now we get 4x squared. Here, 20x plus 12x, those are like terms, so you can combine them to give you 32x. And then that's equal to 60. All right. So now we can solve, right? Because if we can solve for x, remember, if we can get x, then x is the width of the walkway, right? So we just have to solve for, we have to solve this quadratic now. using quadratic formula, or we can use complete the square. Quadratic formula is possible on this, but the numbers are really big. I don't want to have to deal with like squaring 32 and then having to simplify it later. Okay, I'm gonna try doing complete the square. Why? Because the c is already on the right side, so it's kind of already started the process of complete the square because the constant has been moved. Right, the constant is 60. So if we were doing complete the square, remember that the first step is move the c. The c's already been moved, and then step 2 is to divide by a. In this case, my a is 4. So if I divide by 4, I can actually shrink the size of all of those numbers. Okay, so I can divide by 4 to everything. That's going to give us x squared plus 8x plus, I'm going to leave a space here because I know that with complete the square, I need to add something into the left side and the right side. So I'm leaving a space, and then 60 over 4 is 15, and then plus a space. Okay, are you guys with me so far? And can you see why I've chosen to do complete the square instead of quadratic formula? Okay, I see thumbs up. Okay, sounds good, sounds good. All right, so then from here, right, we go with complete the square process. So you take your b value, which is 8, you divide it by 2, and you're gonna square that. So 8 over 2 is 4, and if you square 4, you wanna add 16 to both sides. Okay? All right, so when you factor now, remember that the factor is basically just this term inside your parentheses. So you can then factor this into x plus 4 times x plus 4. And then this is going to equal 31. Now, x plus 4, you can then condense that as x plus 4 squared, which is equal to 31.
I need to get my belt.
So now, go ahead and square root both sides. Square and square root will cancel, and you're left with x plus 4 is equal to plus or minus the root of 31. Okay? All right, so when you solve, you're going to get x is equal to negative 4 plus or minus root 31. All right? Now, remember that the process and the problem we're looking for, this is an application problem. So sometimes you get solutions that don't make sense. Sometimes you do, okay? Now, remember that this right here has given us two different solutions, okay? So remember that what we were looking for at the beginning is the width of a walkway. Well, let's see what these numbers are approximately equal to, right? We can't really tell right now because we don't know the value of the square root of 31. But if we split this up into the two possible solutions, we can identify which one is more likely to be the correct one. Because if we get, let's say, a negative dimension, then that clearly cannot be the size of a walkway because you can't have negative meters for the space of, along a pool, all right? So if I split this up, we can say that is negative 4. One of the possible options could be plus the square root of 31, and then the other could be negative 4 minus the square root of 31, okay? So real quick, let me jump to Desmos. Can you guys still see my screen? Can you guys see the Desmos pop up? No? Okay, hold on. Let me do a new share. Let me do the screen. Okay, how about now? Okay, we're good now. Okay, so remember that the two possible options were negative 4 plus the square root of 31. Okay, that gives us a dimension that's positive, right? It's 1.56. Okay, that seems like that might work. The other solution, just to make sure, we get negative 4 minus the square root of 31. And then that gives us a negative dimension, right? So you can see that one of these just clearly doesn't make sense in the context of the problem. Because it's an application problem, you still have to think, does this answer actually make sense? And if it gives you a negative answer and you're talking about a real dimension in the real world, clearly that can't be the right one. So then that means that if we go back to our problem, okay, this one here is a false solution because you can't have a negative width of a pool. okay? That means that this one is your solution here, okay? And so we can approximate this because we were looking for the width of a pool, remember? So you want to give it in a dimension that people can understand. Here is okay to round the answer, all right? So we ended up with x is equal to, or approximately equal to, 1.5, let me get the exact decimal, 1.567, we could leave it as 1.57. Okay, 1.57, and the dimension, right? Go back to the very beginning of the problem. What units were we talking about? Was it feet? Was it yards? Was it meters? Yeah, we're talking meters, right? So you want to make sure that you list this as x is equal to 1.57 m, or you could just write out meters. Okay. All right. Any questions so far? Yeah, I don't think the math was too bad. I think that the hardest part is the setup. In terms of understanding, like, how do I find the area of a walkway of a pool, right? Understanding what the picture looks like if you're going to have equal size around the entire shape. Okay. Do we have any questions so far? Okay. We're okay so far. All right. All right. All right. Okay. I have one more for you, and then that should take us to the end of the lesson today. Okay. So I believe this next one is a little bit easier. Give me 1 second, please. Okay, sorry about that. All right, so now the last one. Here we go. Okay, so for example, I believe this is example 5. So we have the area of a triangle is 40 square feet. Okay, so we're being told the area from the beginning, all right, which is nice. Okay, and now we have some information about the dimensions. Okay, if the base of the triangle is 8 feet more than the height, okay, they want us to find the height of the triangle. Okay. All right. So go ahead, take a second and copy that down. In the meantime, I'm going to draw a little triangle. Okay, so here's our triangle. And here's what we know about triangles, right? We can call this entire length down here, this part. Let me start over. We can call this entire part right here, this would be our base, okay? B for base. And then if we were to draw a height, remember that the height is the tallest part of the triangle, so we're going straight down, and we can call this our height, right? Okay. If I am looking for the area of a triangle, well, I should at least pull in the formula for that area, right? Because we're gonna have to build something, right? Build an equation. We have missing variables. We don't know the height. We know some information about the base, but it involves the height. Okay, so let's try something. We know that the area of a triangle is equal to the 40 feet squared, right? But let's get more specific. Let's find the formula for the area. The area of a triangle, somebody help me here. I know you guys remember your geo. What would that be? Yeah, base times height all over 2. Okay, so we can do base times height divided by 2. So that gets us to 40 feet squared. Okay. All right. So now, before we move on, let's simplify something for ourselves, right? Let's not work with a fraction. Let's get rid of the 2, right? Let's multiply the 2 to both sides here. So we can just leave this as base times height equal to 80 feet squared, okay? And so now we can just focus on the base and the height. Who's over here sketching on my paper? All right, so anyway, here's what we know, okay? We know that the base of the triangle is 8 feet more than the height, right? So can we convert this base, right? Can we change that into a variable where we're only dealing with one variable, right? Can we say that base is equal to, well, it's 8 feet more than the height, right? So if my base is 8 feet more than my height, I can just take my height and I can add 8 to it, right? And that would tell me my base. I'm sorry about the sound. It's not my fault. You can play in Zoom. Base. All right. So let me just repeat that one more time. I want to get everything into the same variable, right? I want everything to be in terms of h, because that's what I'm looking to find, right? They're asking me to find the height of the triangle. So I don't want to have 2 different variables. I don't want b and h. I just want h. So now, if I take my base, I can convert that, right? Because I know that b, they're giving me some information here that the base of the triangle is 8 feet more than the height, right? So if the base is 8 feet more than the height, I can take the height, add 8 to it, and then that's technically my base, all right? So then now that I know that b is equal to h plus 8, right? I can take this information and I can do a substitution right here. Okay, so base is the same thing as saying h plus 8 times my height again, and then that's going to equal 80 feet squared. Okay, so I'm basically solving a quadratic, but this time I'm not dealing with x, I'm dealing with h. All right, so now you're going to multiply by h, right? The h is on the right side, but you can kind of distribute this going backwards. All right, so h times h is just h squared plus h times 8, that's 8h, and then that's equal to 80. 8 squared. Okay. All right, so again, we're in a position where we could do quadratic formula, but it's almost already in a position where we could just simply do the complete the square. So let's go ahead with the complete the square process. My b in this case is 8, so I can take 8 divided by 2 and square that. So that's going to be 4 squared which is 16. Okay, so then we can go ahead and add 16 to both sides. So now I have h squared plus 8h plus, here's my space. There I'm going to add 16. And then that's equal to 80. And I'm going to just go ahead and add the 16 here. And again, this is all in feet squared. So now here's my quadratic. I'm sorry. Yeah, here's my quadratic. I can then factor this. This is going to factor into h plus 4 times h plus 4. And that's equal to 96. We can simplify the h plus 4. That can become h plus 4 power of 2 and equal to 96. So now we're ready to solve. We can square root both sides. So the square and the square root cancel. We get h plus 4 is equal to plus or minus. And 96 is pretty large. We're going to have to do a factor tree on that so we can simplify and find some factors. So 96, we can do 8 times 12. Let's see. Let me factor 8 into 4 times 2. And then I'm going to factor 12 into 4 times 3. Okay. And the reason I did that is because I know that they have a pair. Here they share a 4, right? So I can pair these up right here. Right, 4 with 4, even though they're across on separate branches, you can pair them up. And then I can box the 2 and I can box the 3, right? Those are the leftovers. So here that becomes 4 square root of 2 times 3. So then 4 square root of 6, okay? So the square root of 96 becomes 4 root 6. Okay. And now we're almost done. Subtract 4 from both sides. Okay, 4 will cancel. And you're left with h is equal to, remember that this 4, the one in blue and the 4 that's in red, those cannot be combined because they are not like terms, right? The 4 in red has a square root of 6. The 4 in blue does not. So they have to stay separate. So what you have is a negative 4 plus or minus 4 root 6. Okay. So here we have a height, right? We have a height, but we got 2 solutions for height. One of them is probably going to be true. The other one is probably going to be false because remember that height cannot be negative, all right? We're talking about a triangle. Dimensions need to be in the positive, okay? So then what we can do is split this solution up into its 2 possible options. So you get negative 4 plus 4 root 6, or it could be h is equal to negative 4 minus 4 root 6, okay? Just take a guess here. Which one is the correct one? One of them has 2 negative signs, and one of them has a negative and a positive. Guess which one is probably going to be wrong. Yeah, the one with 2 negative signs, because you're going to take a negative and you're going to subtract from it. It's going to be more negative, right? So then let's just double check the answer for the one that we think might be right. Negative 4 plus 4 root 6. Okay, so we get negative 4 plus 4 square root of 6. That seems like a pretty decent answer right there, right? 5.79. That seems to be okay with me. All right, so then we can go back. Well, I'm not sure if you guys were able to see the Desmos actually. So here we ended up with h is equal to negative 4 plus 4 root 6. You can leave the dimension like this because h is approximately 5.79, I believe. Okay, so that height seems legitimate versus the other one. If we were to change that to a minus, that gives us negative 13.79. That's not really what we're looking for because height shouldn't be negative. Okay, so one of these is the true answer. This one is true, makes sense in a real world application. Meanwhile, this one does not, right? That's more false. All right. So again, that's my height, but my height needs units because this whole time we were talking about feet. So then this is 5.79 feet, okay? Or give it to me with the exact answer there. Can't go wrong with that. Okay. All right, guys. Are there any questions so far?